Well, I have it almost close to 2, so we will be starting just momentarily. Thank you all so much for joining us today. We have a pretty good chat for you. But just as a start off, just want to run through a couple of housekeeping items. My name is Jenna Quinn, and it's my pleasure as the Assistant Director of Alumni and Affinity Engagement to welcome you all to this edition of the 49er Industry Chat Series. Just so everyone is aware, this is being recorded. And so what that means for you is that it's going to be available for you to watch again on demand on our website at www.csulb.edu/alumni. So you can feel free to watch this again or share it with a friend or a colleague or anyone else you may feel would get something good out of this chat today. And so with that, I am very happy to introduce our alumni speaker today, Jerry Martinez. Welcome, Jerry.
Hi.
Hi. Well, let me just go ahead and read your bio so that way folks can learn a little bit about you. So Jerry Martinez retired earlier this year from NASA's Jet Propulsion Lab in Cañada Flintridge after 40 years in space electronics industry. At JPL, Jerry worked as a failure analysis engineer, a component engineer, hybrid microcircuit source inspector, and counterfeit expert. After earning a BS in chemical engineering at UC Berkeley, he started in the space parts field in the failure analysis lab at Hughes Aircraft and worked on space parts of every kind since then, while also earning an MS in electrical engineering right here from CSULB. Jerry is happy to now continue the good fight against counterfeits, very part-time, however, as a master trainer with IDEA or IDEA. I'm not entirely sure how you call it how you call that, Jerry.
Either.
Awesome. Well, it stands for the Independent Distributors of Electronics Association. Jerry, thank you so much for joining us today.
You're welcome. Glad to be here. Thank you for having me.
Absolutely. And I'll just give it away. I know you have a presentation for us, so feel free to share your screen and we'll get going.
Yep. Okie doke. Okay, this should work. I think you can see my screen now.
That's right. And I think as soon as it goes into presentation mode, I think we're all set.
Yep. All right. Ready to go? You
Ready
see me
to
in
go.
presentation mode? Okay. Hello. Yes. My name is Jerry. I recently retired from JPL, so now I have time to do more time to do things like this. So just who I am and how I got where I am. I was born and grew up in Long Beach. I graduated from Wilson in 1981. I was in the PACE program at the time. You could go to a home school and Poly. So actually, I went to both Poly and Wilson every day. My dad taught at Wilson, so I had to graduate from there. But I was in PACE, and by the time I graduated from Poly High School, I already had 75 AP and college credit units, which enabled me to graduate from Berkeley in 3 years with a bachelor's in chemical engineering. I started working at Hughes Aircraft in their electronic component failure analysis lab. They wanted somebody who was comfortable working with chemicals. I was never expecting to work with electronics, but that's what I started doing. After working with electronics for 6 years, I decided maybe I should learn some of this stuff. So I took a class at Cal State Long Beach, and then another one, and I ended up getting a master's degree from Cal State Long Beach in 1996. My last full-time job, which is the one that I will focus on, because that really summarizes everything that I've done in my career, was at JPL in La Cañada Flintridge, near Pasadena, California. JPL is one of 10 centers for NASA. We specialize in unmanned vehicles. So nothing that we built would have astronauts going up on it. Everything we did was for Earth study, generally satellites, and space probes and robotics. Actually, JPL is operated by Caltech for NASA. So my paychecks came from Caltech, but everything that I did was for NASA. And I worked there as a really in four roles that I'll emphasize today. I worked as a part specialist, which the rest of the world calls a component engineer, a failure analysis engineer, a pre-cap inspector, and a counterfeit part expert. So first, to back up a little bit, what do we do at JPL? These are all projects that I worked on. One of the first ones that I worked on is called InSight. It was a lander, not a rover, so it wouldn't drive around. It just landed on Mars and did its thing. InSight, the mission of it was to monitor Mars quakes. Those are earthquakes, but you can't call them earthquakes because they're on Mars. It was launched and it landed in 2018, and it stopped functioning in 2022 because of storms and windstorms on Mars eventually blew enough dust on it that the solar cells were covered up enough that they couldn't generate enough power for it to continue working. So if we just had a guy with a feather duster up there, we'd be fine. But instead, yeah, it worked for 4 years. One of the more famous ones now, what we called the Mars 2020 rover, which shortly before it was launched was named Perseverance. That is one of several rovers that we have driving around on Mars. Right now, it is analyzing and collecting rock samples, hopefully for eventual return to Earth so that we can do further analysis. Right now, it's only able to analyze with the equipment that it has on board. But the plan is to bring those samples back to Earth for a much more detailed study. Oops. Um, Another one, the James Webb Space Telescope. This has gotten a lot of publicity. This was actually headed by Goddard, NASA Goddard, but JPL built the mid-infrared instrument. So really this telescope, which is launched in space, it's sitting in space in one of the Lagrange points, so it's stationary, studying what's out there. The two main telescopes out there are Hubble, which can see things with visible light, and James Webb, which sees with infrared. Infrared can penetrate space dust, so it can see things that Hubble can't see. And this is just an example, just showing this slide is an example of how important attention to detail is in what we do. So the third bullet there is emphasizing the difference between the two pictures. The picture on the left is the James Webb Space Telescope unfurled on Earth. And I don't know if you can see my point. Even I can't see my pointer. Anyway, oh, there it is. So just below this this crane, this hoist, there's a person. It just gives you an idea how huge this telescope is. Well, that had to fit into a rocket. So on the right is a picture of what it looks like all folded up so that it could be launched. To get it unfolded required 344 different steps before it could be functional, and everything had to work right. So one big thing for NASA is attention to detail. Everything has to be done right, because if something doesn't work, you can't go up and fix it. And you may have seen some of these pictures. These are pictures that have been published a lot lately. So just 2 points. Since James Webb detects things with infrared light, that tells you that all the pictures that you see from the James Webb Space Telescope are false color. Those aren't the real colors. If they were the real colors, we wouldn't be able to see them. So these have all been translated into colors that we can see and look like something that would make sense to us. And then the picture on the upper left, the point of that one is that um, it was decided to point the telescope to just something that looked like black space, that looked like there was nothing up there. Nobody could see any stars or anything around there. It just looked like there was nothing there. And as you can see, there's a lot in there. You might think those are all stars. Some of those are galaxies, entire galaxies. They're just so far away that they look like points of light or disks. Another one, this launched a year ago. It's called Psyche. This is a space probe that's going to an asteroid in the asteroid belt called 16 Psyche. It's going to take 6 years to get there. The main reason why we're sending it to this particular asteroid is because it's believed that this asteroid, since it's almost entirely metal, we believe, is either the core of a planet that broke apart or the nascent core of a planet that never formed. Uh, this is to help us understand our solar system and perhaps our own planet, because it's oddly, it's easier to study another planet or an asteroid than it is the core of our own planet. Excuse me. Then, yeah, the last one. This is the Europa Clipper space probe. This is launching in just 9 days to go to Jupiter's moon Europa. The unique thing about Europa is that it is largely covered with water ice. There's water on Europa, and at least as we think of life, uh, water is essential for that. So we're looking for signs of life, anything that may have existed in the primordial Earth, and that's going to get there in 2030. What I did at JPL, my official title was part specialist, or as most places call it, component engineer. But really, I did a few different things. As a part specialist, my main job was to manage high reliability space electronic parts. High reliability because, again, they can't fail. I was assigned to various things as needs arose: crystal oscillator hybrids, which are extremely accurate timing devices, thermal sensors, and relays. So what I did for that is I managed the requirement specifications and made sure that the parts that we used satisfy mission requirements. Requirements for space vehicles are generally pretty different from for cars or consumer electronics. For instance, it gets really cold on Mars, so we have to make sure that parts can tolerate that. For Jupiter and its moons, Jupiter is extremely radioactive, so we need to buy radiation-hardened parts, or they have to be put into a special vault which shields them from radiation. I also dealt with problems, manufacturer production problems, failures of all part types, because that's what my experience has been through my career. And when parts didn't meet our requirements, we had to do risk assessments to see whether we could still use them. I also inspected hybrids, hybrid microcircuits, 100% prior to package seal. A hybrid microcircuit, in case any of you don't know, is it's basically a little box with a bunch of electronic parts in it. It's called hybrid because hybrids use both integrated circuit and discrete part technologies. So there might be one or more IC chips, like computer chips, along with resistors, capacitors, diodes, transistors, whatever, all put into one box. And the way most space companies do things, before a hybrid is manufactured and sealed, somebody has to inspect. Somebody from outside the manufacturer's company has to come and inspect every single one. And that was something that I did. And the last thing, I also ensured that counterfeit electronic parts didn't end up in our spacecraft. And I'd been doing it long enough that I ended up teaching the counterfeit avoidance classes for JPL and for all of NASA. Counterfeit electronics has become a really big deal in the last 15 years, when about 15 years ago the government realized just how many counterfeit parts are in military hardware. They were getting failures in the field which were not tolerable, and they figured out, okay, a lot of these are because of counterfeits. Where I worked, I have two pictures. A lot of my work was in an office, and I liked to surround myself with things that made me happy, like music. I also worked in labs, manufacturing facilities, and clean rooms. So this is a picture of me doing a source inspection at a manufacturer facility. We need to make sure that we're not contaminating the parts that we're working on. So I had to wear a bonnet to cover my hair, face mask so I wouldn't get spit on anything, and this is long before COVID. On my fingers, there are finger cuts. You can use either rubber gloves or just little rubber things that go over each finger, depending on what the facility uses, to make sure that I don't get finger oils on the parts that I'm inspecting. And on my wrist, you see something that looks like a blue watch that doesn't have a dial with a little cord attached to it. That is a wrist strap. And what that does is that grounds me so that I'm not electrically shocking any parts with by electrostatic discharge, which can destroy them, or what's worse, damage them. It's really worse if a part is just damaged a little bit but still works, because it would probably fail prematurely later on, and that's the worst. What I did, component failure analysis. It typically takes a few years to build a spacecraft, and the whole step along the way, there's constant testing going on. So they'll take a few electronic components and solder them onto a board, and then test the board, and then put a few boards together to make a subassembly, and test the subassembly, put various subassemblies together to build an assembly, and test that. And the testing is not just electrical, it's over temperature and thermal vacuum, vibration and shock tests. And anytime anything fails along the way, after troubleshooting identifies what component failed, it would be sent to a lab and we would figure out what went wrong. So this was an easy one. This is a very simple integrated circuit which blew up. Too much current was passed through it, and then you do a little circuit analysis to figure out where the current was going. Here's another one that is actually, this is not any optical pictures. These are all computed tomography images. Computed tomography is like X-ray, but in 3 dimensions. So it compiles a 3-dimensional X-ray model of a device. This is the rotor of a motor that had multiple open circuits. And by looking at it with computed tomography, in the kind of middle picture, you can see that there are some breaks in these wire windings. And then in the lower right picture is actually a virtual cross-section of the same area. In the first 2 pictures that you're looking at, only metals are visible. Everything else has been digitally filtered away. In the lower right picture, we are also seeing the encapsulant. There's an epoxy encapsulant material that coats this whole thing. And you can see that the epoxy encapsulant has cracked. Well, this is a hard epoxy, and when it cracked, the wires embedded in it also broke. So we were able to determine that the problem was an encapsulation issue. You may not have seen what computed tomography looks like. It's like a medical CAT scan. So here is a video. Hope you can see it. This is looking at a three-dimensional representation of only the metals in this motor rotor, looking from different angles. And okay, now we have just shifted to a 2D view. Let me back it up a little bit. So now we're looking at a virtual cross-section. So in the first views we saw, the epoxy encapsulant was digitally filtered away. In this view, the dark areas are epoxy encapsulant, and you can see some black cracks in that. And that's how we were able to figure out what caused the failure, not just locate the failure site, but determine the root cause. Pre-cap inspection. As I said, one of the things that I did is I inspected hybrid microcircuits. At the upper left is a pretty simple one with one integrated circuit chip at the lower right, and then a bunch of other passive elements. On the right side, that is a quartz crystal oscillator hybrid. So at the upper left of that picture, that round thing is a quartz crystal, which oscillates at an extremely precise frequency, and the rest of the circuitry is driver electronics. And then at the lower left, that is a more complicated hybrid microcircuit. All of these have to be inspected. Each element on there has to be inspected to make sure that there's nothing wrong with it. And that's one of the things that I did. As an example of something that can go wrong on one of these, at the upper left, that's an overall view of one of the integrated circuit chips in a hybrid. Lower middle is a magnified view, and it doesn't look too bad, but if you look closely enough, you'll see a couple of areas that don't look quite right. And in the picture on the right, there are two areas in particular that also don't look quite right. And what happened is that it looks like something came down and smeared the metal. Now, the one at the upper middle is not a big deal. That's more of a cosmetic thing. It doesn't look great, but it's probably not an electrical problem. The one at the lower middle, if you can see my cursor around there, the metal has smeared close so that the metal of one conductive line is extremely close to the metal of another conductive line. That's really bad. Now, this device still works, but over time, metal can migrate or something can break off, and you end up with a short circuit, and that would cause a premature failure. Similar thing on this one at the upper left, that's an overall photo of a monolithic microwave in an integrated circuit. And in that picture toward the upper right, the big gold square thing is a capacitor. And the picture on the lower right, this is where the two polarities, or the two electrodes of the capacitor are connected. And the kind of yellowish greenish thing is supposed to be an insulator. That's supposed to be an insulative barrier between the two gold areas. And again, you're seeing gold smeared so that it's almost making contact. Again, this part works right now, but we would expect it to fail prematurely. So this is the most important thing to try to get out of manufacturing process line before it gets sealed, so something like that is never put onto a spacecraft. What I avoided, counterfeit electronic parts. As I said, about 15 years ago, this really became a big problem, and it's a combination of buying things from questionable sources and people not even thinking of knowing what to look for. So all of the parts that you're seeing on this screen are counterfeit. The one on the upper left, that's what's happened to this one is called black topping. What counterfeiters would do is they would take a cheap part and paint over the markings with a black material and put new markings on it of a more expensive or more rigorously tested part. This one is very obviously black top, so that's easy to spot. The other ones are a little more subtle. And then at the bottom right, that's an X-ray of 3 components, which are all supposed to be the same, but you can see in the X-ray that the lead frames are different. They are not the same. As I said, I've retired from full-time work, but as soon as I retired and I was letting people know that I'm getting out of the counterfeit world, I got a phone call from a friend who is the director of IDEA, the Independent Distributors of Electronics Association, and they literally wrote the book on counterfeit inspection. On the right, that is the book. That's a standard that came out in 2010. It's the first standard that was ever put out for how to inspect for counterfeits. At the lower left is when I was first trained and certified in 2013. So now I am their trainer. I'm updating course materials and buying sample parts. And soon we will be offering training classes, like the one that I took, but they haven't been offering them for a while. My networks. This is the kind of thing that will help you out sooner or later in different ways. If you started working, then LinkedIn is a good place to get on. And that's a way that I've maintained professional connections that I've made over the years. If anybody wants to look me up, that's me. My formal name is Gerald M. Martinez, so that's my LinkedIn address. For at least 10 years, I'd been going to this symposium on counterfeit parts and materials, which is led jointly by the University of Maryland's Center for Advanced Life Cycle Engineering, that's CALS, and the Surface Mount Technology Association. I've been very involved in that. I attended for many years. I've written and presented papers, moderated sessions, served on discussion panels, and for the last few years, I had served on the technical committee that organized and planned the symposia. And actually, this is what got me the job that I'm working on now. As soon as I announced that I was retiring, the job came to me. When I was doing failure analysis for a living, I attended the International Symposium for Testing and Failure Analysis. And I attended that for many years and also presented there. Something that whatever field you go into, if it involves hardware of any kind, you may hear about SAE committees. The SAE is the Society of Automotive Engineers. It used to be called the Society of Automobile Engineers when all they dealt with was cars, but they decided they wanted to be involved with airplanes, aircraft, spacecraft. So they changed the name to Society of Automotive Engineers, and that's supposed to incorporate other types of vehicles. There are a whole bunch of different committees. The G11 and G12 committees, which deal with respectively with passive and solid state components. These committees meet 3 times a year for a week at a time in different parts of the country. The main emphasis of these organizations is to work on military specifications. like it or not, whether you like military things or not, that's one of the few places, one of the few ways that that component specifications can be rigorously controlled. So it's actually the Defense Logistics Agency, excuse me, which manages mil specs, but these mil specs contain the highest requirements for electronic components. So many different fields use mil spec parts. And where we discuss new technologies or new requirements or requirements that need to be improved is at these G11 and G12 meetings. I have met a lot of people that way and really increased my network that way. The Society of Automotive Engineers also has a committee on counterfeit electronic parts that's called G19, and I helped write a couple of standards with them. And just something else to mention, soon after I graduated with my degree in chemical engineering, I joined the American Institute of Chemical Engineers, and there's also IEEE, Institute of Electronics and Electrical and Electronic Engineers. I'm just saying they could be good. I just was never active in them, but especially if if you're a student or will be graduating soon, those would also be good ways to build your network. And then finally, what keeps me sane? Um, these are just things that I have made sure to keep um, as priorities in my life. Um, I I work to live. I don't live to work. There's much more to life than work. So my wife and I have been married for 40 years. Maybe one reason is that we don't have kids. We have cats, we very much enjoy them. The other thing that I'll mention on here, the third bullet from the bottom, a favorite show of mine, which fortunately my wife likes also, on the Smithsonian Network, there's um, a series called Air Disasters. Especially with my interest in failure analysis, that's basically what this is. The air disaster, each air disasters episode focuses on generally one, sometimes three different either plane crashes or near misses. They go through the investigation of what went wrong and what corrective actions can come from it. So um, a lot of the analytical techniques that I've used over the years, I see on that show, which is kind of fun. And the last thing that I'll mention, the very last one on the list, staying true to myself. Um, that can mean a lot of things to a lot of people, but I will just say that over the course of my career, many times I have had to decide whether to what do as I'm told or do what I think is right. Um, as I said, in the space field, there are lots of requirements, lots of procedures and processes for how to do things. And those generally have to be followed rigorously. And I do. Um, but there are a lot of other things that come up, just decisions that have to be made, um, especially involving management, where management might tell me to do something that goes against my judgment. So then what do I do? Do I do as I'm told to make my manager happy? Um, or do I risk losing my job? Because if you don't do what your boss wants, that's insubordination, and that is often grounds for termination. So I would end up questioning things a lot and challenging things. I would do it professionally and show that I'm interested in doing the right thing. That's my motivation. But there are many times when I've had to really put my neck out there and take a chance. Um, because I've wanted to do what's right and not just take the easy way out and do as I'm told. And that's what I've got. And I'm going to stop sharing now.
Awesome. No, thank you so much, Jerry. That was absolutely a fantastic presentation. I got to say, you and I learned something new about you. You and I share a love of cemeteries and grave sites. We are often, me and my wife are often on findagrave.com, so that's super cool. We'll have to exchange some of that. But yeah, I just
And
wanted
just,
to
oh, for
go ahead.
people who don't know, Find a Grave is it's an excellent website. It's also an app. You can download an app on your phone wherever you are. You can find whatever cemeteries are nearby. And I like the old ones. So just putting that out
Love the old ones. Oh, okay. We got to connect over that later, Jerry. But
there.
right now, down to business. We got some great questions coming in the chat. So if you've already submitted, we're going to get to those ASAP. But if you haven't, please go ahead and we'll just go through them. Before we get started with the ones that have been submitted, I just kind of want to ask what brought you to this industry in general? Like when was the time when you knew that this was what you wanted to do? Was it something that was really intentional for you, or was it kind of something that you fell into? How did you find yourself here?
Good question. I had I had long been interested in engineering. I had long liked science. Um, so I figured I'd be going in some direction in there. And as I mentioned, my bachelor's degree was in chemical engineering, so I was expecting to work for a utility, and that's something I wanted to do, was do something for the common good, not for the profit of just one company that's out for its own good. Um, so I really fell into um, working at Hughes Aircraft, which actually at the time was a nonprofit. That's another story. Um, it benefited the Hughes Medical Research Institute. Um, I kind of fell into that, and um, after a few years, realized I'm good at this. I have an analytical mindset, just a way I think, um, and I could tell which engineers were going to make it in the field of failure analysis and which ones weren't by whether they were able to analyze, figure things out, and that's just where um, I'll say where God put me. I was not expecting to go there, but that's where I ended up, and it worked.
Awesome. Well, let's dive right in. I think this one was a question from earlier in the chat, but Oscar wants to know how big is the lander compared to the Perseverance rover? I think in reference to those
Oh,
pictures.
yeah, the Perseverance rover is probably about the size of um, maybe a little bit bigger than a smart car, um, and the lander is a little bit smaller than that. It's kind of hard to compare. The solar panels make it look bigger, um, and it's got things sticking out of it. So like the Insight lander just has legs that it's sitting on, but it also had a thing coming out of it with a drill at the end to drill down into the surface of Mars to basically plant a sensor that would be monitoring vibrations at different depths.
Well, I think you picked the right comparison point there with the smart car. Apparently, that's what Oscar drives.
Wow.
Sophia would like to know, what are some of your suggestions that you have to build job experience to work in bigger aerospace companies or, NASA, you work for JPL. Yeah, more of a practical question, but like,
Mhm.
how do you build that job experience and that work history?
Um, a lot of places offer internships. That's a great way to get your foot in the door. Um, unfortunately, and generally JPL is really good about that. We've had a lot of interns, but everything that JPL does is funded by Congress, which is funded by taxpayers. And one of our big projects that we've been working on for years, actually, Congress decided they didn't want to fund it this year. So already this year, we've laid off somewhere around 700 people. I don't know how many internships JPO will be having in the very near future, but hopefully before you guys graduate, there will be other opportunities there. Other companies working with professors on projects. I'll just say whatever experience you can get, whatever things you can learn, go for it. I had no idea I would become a counterfeit electronics expert when I was uh, working on my master's at Cal State Long Beach. But an opportunity came up, and I learned it, and that became a thing for me, and I built up a whole network around there. So there was a Jim Carrey movie, probably from the 90s, called Yes Man, and he decided he was going to say yes to anything, any opportunity presented himself. And the movie got silly. But most things worked out pretty well. And I would say, um, without violating your boundaries, you need to take care of yourself. Don't overwork yourself. Don't sacrifice yourself for a company or whatever. But whatever opportunities come your way, take a chance. Learn something. It might be something that you've never heard of that really grabs you.
Yeah, no, that's great. We have a question diving a little bit more into internships, and it might be a good way to phrase it more like, if you were looking to hire an intern, what type of information would you like, someone either in college or fresh out of college to kind of put in their resume, or how would they kind of stand out, at least to you in your professional experience?
Another good question. Um, what I would be looking for, unfortunately, is things that are relevant to the job at hand. And almost everything that I said is something that I did not learn at Cal State Long Beach. There just aren't classes on how to inspect components or even how components are constructed or made. Um, but everything that I learned was the foundation that I could build on. So I would be looking for what is the foundation that this person has, and um, is it something that I think would enable them to learn these things pretty quickly? And it's really hard to stand out on a resume. I learned a lot more from interviews, and I would just say, be eager, be willing to, like I said, do things that may be outside of your comfort zone or outside of your experience. Um, it's great working with people like that.
Yeah.
And that's what I look forward to. What I don't look forward to is when somebody has to be told every step of something. And I mean, it's good to ask for help when you need it, but I appreciate initiative. Um, if you can think of a better way of doing something, or if you think something might be a better way, bring it up, suggest it. If you get shot down, well, you've learned something. That's fine. Um, but yeah, just be a go-getter, go for it. Don't just be passive and do as you're told.
Awesome. No, great advice. Great advice, I think, throughout a career, right? Um, and so uh just one of those hot button questions, right? I know that we are, as a society, seeing such advancements and such a rise in AI, artificial intelligence. What role do you already see or anticipate seeing artificial intelligence playing in your specific industry, in your specific field? Is it
Mhm.
something that it can help, or is it something that can kind of get in the way?
Yes, both.
Yes
Um,
to both.
yes. Um, I have never used it in my job, but last year So one fun thing about JPL is we bring in speakers to talk about various issues, some just personal development or health, but a lot of them, of course, are relevant to our jobs. We had a speaker last year who came to talk about artificial intelligence and how it could be used at JPL. The main guidance I would say is that it can help a lot, but don't trust it. It
Okay.
makes things up. It seems intelligent, but it's not. It's just compiling what it sees out there. And as we know, a lot of what's out there is not good. So for instance, one piece of guidance we were told is, let's say you've got a technical paper that you've published and you need to make a PowerPoint presentation about it to management. You can have AI do that. You can tell it, take this content, I need 10 slides of it, I would like 5 bullet points per slide, whatever, and it will digest everything and put it in the format that you want. That's cool. You still have to go through everything. You have to check everything. So whatever you do with artificial intelligence, it can do so much processing and thinking faster than we can, but it's still artificial. It's not actual. You have to use your actual intelligence um, to um, to make sure that what it's saying is correct. There's an old expression about being able to tell poop from shinola. Shinola is an old type of shoe polish. Um, AI cannot necessarily tell poop from brown shoe polish. You've got to do that yourself.
Well, thank you. Great piece of advice. Um, and I want to obviously, Jerry, thank you so much for your time. This has been just a really great chat. For folks who, maybe have some more questions for you, or might want to continue the conversation, or get in touch with you after this chat, is there a best way for them to do that?
Sure. Probably the best way is on LinkedIn, and I've just typed my LinkedIn name into the
Username.
chat. Yeah, yeah. You
Awesome.
search for Gerald M. Martinez. My name will come up as Jerry, but that's only been since I retired. When I was actively working, I kept it formal, so my name was Gerald M. Martinez. But yeah, feel free.
There you go. Awesome. Well, thank you so much. And feel free to reach out to Jerry for any help with networking. Um, I know that he has a lot of resources that are available to him. Like I said before, this, for those of you who are here, this is going to be available on demand on our website at www.csulb.edu/alumni. Also, feel free to follow us on any of our social media channels, so that way you can catch the next industry chat, and hopefully join us again soon. Until then, I just want to say thank you so much for joining us, and have a great day. Bye-bye.
Thanks, you too. Thanks for having me.